Hey guys, welcome to your Chapter 8, Lesson 7 notes on factoring special cases. By the end of the day, you'll be able to factor both perfect square trinomials and trinomials that are the difference of two squares. Now, perfect square trinomials are both these guys, because they're both either a sum or a difference squared. And then a difference of squares is going to be this guy because he ends up being two square terms and then the difference between them. Okay. By the way, if I sound a little bit congested, I'm sorry, but here we go. You know what? Let's work backwards just for funsies. So the difference of squares is this guy, because if you FOIL it out, you'll end up getting a squared plus ab minus ab minus b squared, and that's it. So that's the shortcut that way. And then if you factor them out, just kidding, if you FOIL this guy out, you would get a squared plus 2ab plus b squared. You can check my work by FOILing it out, and then this guy ends up being exactly the same thing, except since there's a minus inside, the minus 2ab becomes a minus. So that's a fun shortcut. Now today we're going to take those things and we're going to go backwards. We're going to start with trinomials, or in this case a binomial right here that looks like that, and then we're going to end up with the factored form, which is those guys right there. Yay. Oh, this is because factoring is like multiplication, but you're just going backwards. Factoring is like listing all the factors. It's saying what would happen if you divided by something else. So here's how to recognize our two kinds. We've got our perfect square trinomial, which is either a plus b or a minus b. And look, it made me draw a perfect square. That was not intentional. And then we have the difference of squares, and it's not going to turn out to be fitting well in there, but there we go. We can just do that. Sure. Haha. Okay, now they work. Okay. So perfect square trinomial is always going to take this form of a squared plus 2ab plus b squared. So in order to check that something's a perfect square trinomial, you check that the first term and the last term are both perfect squares. That is, no matter what they are, they're equal to something squared. For example, a squared is a times a, and b squared is b times b. And then whatever that is, the middle term, the guy in the middle, needs to be equal to 2 times their square roots. So we'll look at examples and see if they fit those patterns or not. Let's do that now, and then I'll jump back. Okay, so I could check that each of these is a perfect square trinomial by looking at those rules. First, is m squared a perfect square? Yes, because its root is m. So that's m squared. Okay, and then 49 is 7 squared. So these are both something squared. And then our middle term needs to be 2 times m times 7. So it's 2 times those roots. Hey, look, that does totally work. Now that we know what our things are, we can factor that as being our perfect square trinomial. So it's going to be equal to something times something, and we know those somethings are, something plus something squared. Those somethings are m plus 7 squared. We can check this out by saying, okay, well, what's m plus 7 squared? That's m plus 7 times m plus 7, and then FOIL it out. So right now we're saying, hey, you know what? Does this trinomial, does this actually equal m plus 7 squared? Well, let's find out. Let's FOIL it. So that would give us too big of a bridge. I'm so sorry about that. M squared plus 7m. I'm doing this in a really weird order. I'm sorry. Doesn't matter though. Plus 7m plus 49, which is m squared plus 14m plus 49, which, hey, what a coincidence. That's exactly what we started with. Therefore, this is how to factor it. Okay? Now this guy, does this fit a perfect square trinomial? Well, is this something squared and is this something squared? Yes, it is. N squared is n squared and 36 is 6 squared. Okay, cool. Now our middle term, is he equal to 2 times n times 6? Not quite, because we have a minus right there. So that means we need to make this negative 6, because 36 is also negative 6 squared. So we needed to make this a negative so that we would get a negative 12 here. Yay. Alrighty. So that tells us that the factored form of this is something squared, and that's going to be n and negative 6. Or if you don't like to write n plus negative 6, you can just say, oh, that's n minus 6 squared. Ha! And that's fine. Now the good news is, if you don't recognize that it fits this shortcut, that's okay. You don't need these shortcuts. You can just straight up factor it. You can say, oh, n squared minus 12n plus 36. Okay, well, let's see, I know that I've got an n squared here, so this needs to be n squared. So we've got n, and I've got a 36 here. Okay, so this needs to be a 36. And then whatever goes in here, they need to add up to a negative 12. And eventually, after trying some combinations, you would get minus 6 and minus 6. And you would find out, oh, hey, it's n minus 6 times n minus 6. Sweetums, which is n minus 6 squared. Now be careful, because your perfect squares on front and back might be a little bit hard to find, but that's okay. Because check it out, 4p squared, that's kind of complicated. But wow, what happened? I don't know. But that's still equal to something squared, because I'm going to do a little baby step in between. I'm going to show you that this is actually two things that are squared. That's, well, 4 is 2 squared, and p squared is p squared. So undistributing the square gives us that is 2p squared. Fancy, right? Whoa, so cool. And 25, well, that's just 5 squared. Yay. So now the question is, ooh, 20p. Is that equal to 2 times our square roots, which is 2p and 5? It is, because that's 4p times 5, which is 20p. Okay, so now we get our square is 2p plus 5. So that's our perfect square pattern. And now, let's look at our difference of squares. Our difference of squares is my personal favorite kind of factoring situation. It's the plus and the minus guy. So a difference of squares is what happens when you have a difference of two things that are squared. Okay, so you check again that the first and last terms are in fact perfect squares. But this time, instead of having a 2ab between them, there's just a little minus sign between them. That's it. I'm a cough. I'm sorry. Oh, cute cough. Hey, look. Difference of two squares. Man, I tried to take a subtle drink, and I do not think that ended up being very subtle. Okay, difference of squares. You need to figure out, hey, is this something squared? And is this something squared? Well, yeah. Oh, I made this all the wrong color. Well, yeah. Q squared is Q squared. 64 is 8 squared. So that fits into our perfect square. Nope. that fits into our perfect square pattern of q plus 8 and q minus 8. And that's it. That's as far as we can factor. Man, I got a tickle in my throat. I hope that it doesn't last this whole video. Okay, this is the same thing as r squared minus 10 squared. And that fits our perfect square pattern, which is a plus minus guy of r plus 10, r minus 10. That's it. That's as far as we can factor. Ooh, look, a funky square. Okay, we just got to figure out what is this squared and what is that squared. Well, 9s squared is the same thing as 3 squared times s squared. So that is 3s quantity squared minus 4 squared. So to fit into our perfect square pattern, that's plus minus. And we are all set. Cool, huh? All set. Now you guys have all the tools, you have all the tricks under your belt to help you solve all these problems. And my hint for you is do what you can. When life gets complicated, just do what you can to try to make your life a little bit easier and see what you can do. Because look at this. Oh boy, that looks tough. But I noticed I got another cough. I'm so sorry, guys. Okay, maybe that did it. They have a GCF. I noticed they're both divisible by 5. So I'm going to get rid of that and see how that helps me. So that is equal to 5 times 16 is 80. Okay, and 5 times 9 is 45. Nice, cool. All right, so I factored out a GCF. I also noticed that those are both squares. Man, I don't know what's up with my throat today. But that's 4v quantity squared minus 3 squared. So yeah, I've got a 5, but even inside here, I've got a difference of squares. I've got a 4v and a 3, and a 4v and a 3. So I broke down this situation as a difference of squares into my plus minus guy, and now I'm all set. That's my factored form, and I did that whole thing. Isn't that awesome? And this guy, he looks way too complicated. I mean, it's deceptively simple. It's not so simple, but that's okay. We'll factor out a 2, giving us a w squared minus 1. And looking at it, that w squared minus 1, he looks done, doesn't he? But guess what? That's still a difference of squares, because that's w squared and 1 squared. So that gives us a difference of squares, which is a plus minus combo, w plus 1, w minus 1, and now we're all set. So if you guys forget your shortcuts, that's okay. You can always use whatever factoring you like best, and that's great. But these shortcuts are super helpful, and you know what? Just take it one step at a time, piece by piece. Do what you can in algebra or in real life, and you'll get there. Yep. Have a great time on your homework.